Now that we've talked about the definite integral properties, let's put them into practice. So got an example on the board right here. We see that we have f of x, the integral from 2 to 7 of f of x is equal to 3. And we've also got another integral. This time it's from 7 to 2. It's of another continuous function, g of x, and that's equal to 2. So that's what's given to us. And our charge is to find the integral from 2 to 7 of 3 g of x dx, and then after we're done with that problem, the integral from 2 to 7 of the quantity 4x plus 1 dx. All right, so we have to put the properties in use that we've already talked about. Let's tackle 1a first here. All right, so the integral from 2 to 7 of 3gx dx. Okay, now we see that 3 there, and it's coefficient. We know that coefficients can move out of the integral, and they can move out front, and then we can work with just the remainder of the integrand. So what do we have here? We have the 3 going out front, and 2 and 7 are still our bounds, and we have g of x dx all alone in the integral now. Now, why does that help us? Well, because we've got g of x all by itself up here in the given. All right, so the integrands match, which means that we can now do some substitution. There's one small catch, and that, as you've noticed, is that our bounds of our given are from 7 to 2. The bounds in our problem are from 2 to 7. So we need to change our bounds, okay? And remember what the property says when we want to change the bounds. We're going to swap the bounds, if you will, of the integral. We're allowed to do that. The only change is that the value is negated. So if the integral from 7 to 2 of g of x dx is 2, then the integral from 2 to 7 of g of x dx is going to be negative 2. So this product ends up being 3 times negative 2 for a final answer of negative 6. Okay, that's our solution. And that's a type of problem that they're going to place at some point on the AP exam in all likelihood. It'll be a touch more complicated, similar to Part B. But ultimately, what did we do for our properties with Part A? We used the coefficient property where we're allowed to move that out front, and we used the swapping of the bounds in which we negate the value of the definite integral. Okay, let's go to number 1b here, where we see the integral from 2 to 7 of 4 f of x plus 1. Okay, so we're given that the integral from 2 to 7 of f of x dx is equal to 3. And you may be looking at this quickly and saying, okay, 4 times 3 is 12 plus 1 is 13. And 13 actually is not the correct answer, but your thinking overall, at least initially, would be correct. Okay, we want to do the same thing to the 4 that we did to the 3 up here. We want to push that out front. We also see that we have a sum in our integrand, and we're allowed to break that up into 2 parts. So what do we have here? We have 4 times the integral from 2 to 7 of f of x dx plus the integral from 2 to 7 of 1 dx. Okay, so we use 2 properties again. The coefficient property of moving the coefficient out front, and then the sum difference property where we're allowed to break this single integrand up into 2 integrands. Okay, now the integral from 2 to 7 of f is given to be 3. So we can absolutely use that. We know that we have 4 times 3. Now I'm getting down at the bottom of the screen there. Okay, what's going on right here? The answer for the second integral is not 1. Okay, remember it's the area between 1 and the x-axis as x goes from 2 to 7. So again, what you may want to do is make a quick picture. And if we do that right over here, okay, we have the graph of y equals 1. There it is, y equals 1. I think that barely fits on the screen there. And we're going from 2 to 7. All right, so if we make this rectangle here, we see that we do in fact have a rectangle with a height of 1 and a base of 5. So this area between the function y equals 1 and the x-axis from 2 to 7 will be 5. So we actually have 12 plus 5 as opposed to 12 plus 1. So our final answer of 17 is where we're heading. And this idea of making sure that you don't do plus 1, but in fact you do plus 5, that almost definitely will come up on the exam.